morning, students. In second chapter of class 11th atom structure, the last topic is shapes of atomic orbitals. According to Max Born, the square of the wave function at a point gives the probability density of the electron at the point. Wave function psi square is shows the probability density of the electron at the point. For first s or 1s orbital, the probability density is maximum at the nucleus and it decreases sharply as we move away from it. That means as the distance of the energy level increases, density of electron from the nucleus also decreases. For 2s orbital, the probability density first decreases sharply to 0 and then again starts increases. After reaching a small maximum decrease against and approaches 0 as the value of r increases further. The region where this probability of finding an electron reduces to 0 is called nodal surface or simply nodes, where probability being 0, that is called nodal surface or simply nodes. In general, for an ns orbital, an ns orbital has n-1 nodes, that is number of nodes increases with the increase of quantum number n. Therefore, 2s it will be 1 and for 3s it will be 2 nodes. Boundary surface diagrams of constant probability density for different orbitals give a fairly good representation of the shapes of the orbitals. In this representation, a boundary surface or a contour surface is drawn in space for an orbital on which the value of probability density is constant. In the boundary surface diagram, the nucleus is taken to be at the origin, or rather it is. Their diagram are not spherical like the s orbital. Here, the p orbital consists of two sections s called lobes. They are on either sides of the plane where the two lobes touch each other. The size, shape and energy of the three orbitals are identical. Since the lobes are considered along the x, y and z axis, they are designated as the above 2px, 2py and 2pz. It should be understood that there is no relation between first magnetic quantum number and xyz directions. Boundary surface diagrams for 2p orbitals. Two lobes are there of s orbitals in x orbital and in p, 2py and 2pz. That means total 6 orbitals are there or 6 lobes are there, 2 in each axis. Now d orbitals, 5d orbitals are designated as dyz, dxz, dx square minus y square and dz square. The shape of the first 4 d orbitals are similar to each other, whereas the fifth one is different from others, but all 5 have 3d orbitals and are equivalent in energy. The d orbitals for which n is greater than 3 also have shapes similar to 3d orbitals but differ in energy. When two nodal planes pass through the same origin and bisecting the xy plane and z plane, these nodes are called angular nodes. Angular nodes are denoted by L, means azimuthal quantum number. There are one angular node for the p orbitals and two angular nodes for d orbitals. The total number of nodes are given by n-1, that is the sum of L angular nodes are n minus L minus 1 radical nodes. Energies of orbitals. Energy increasing order in the orbitals is given as follows. Less in 1s, 2s and 2p are equal, then greater of 3s, 3p and 3d, 4s, 4p, 4d having the equal energy and up to 4f. That means as the number of shell increases, distance from the nucleus increases, energy increases. As 2p and 2s orbitals are different, an electron has the same energy as it is present in the 2p or the 2s orbital. The orbitals which have the same energy are called degenerate. The 1s orbital in a hydrogen atom corresponds to the most stable conditions and is called the ground state, and an electron residing in this orbital is strongly held by the nucleus. The electrons residing in the 2s, 2p or higher orbitals in the hydrogen atom are said to be in the excited state. The attractive interaction of an electron increases with the increase of the positive charge on the nucleus. Due to the presence of electron in the inner cells, the electron in the outer cells will not experience full positive charge of the nucleus. The effect will be lower due to partial screening of positive charge on the nucleus by the inner shell electron. This is known as shielding of outer electrons from the nucleus by the inner shell electrons, and the net positive charge experienced by the outer electrons is known as effective nuclear charge. In other words, the energy of interaction between the nucleus and the electron decreases with the increasing atomic number. Next time I will explain above principle and other some terms. Up to that, I hope so you understand why the shape is different of different atomic orbitals due to different in their energy and the space which get by the electron. More electron, less space there, so the shape of the revolving around the nucleus is different. In S orbital only one or two electrons are there, totally half sphere is available to remove, so the size of the s orbital or the shape of the s orbital is a sphere. But for p and d, no space, more space are available for 6 or 10 electrons respectively. Therefore there are some lobes formed to revolve around the nucleus. The point at which the possibility of the or probability of the electron presence 0, that is nodes, it is up to the nucleus, and as it's away from the nucleus, its possibilities to obtain or presence is more, so there is forms a wide place like a petals of a flower, that is called lobes. S, P, D and F are the four types of orbitals, you know that. So in S, spherical shape, in P, single lobe cell, D, double lobe, and F is complex type of structure. If you try to know more about this, you can search it in internet and can find it. This is all for today. Thank you. I will explain another portion of this in my next video. I hope so you understand it better. Again, I thanks to watch this video. Thank you very much.